Okay, hello everyone. Today our group will be presenting our finding on lab 1, which focuses on design and analysis of disc brake rotor. We will be walking you through the material properties, cultural result for different disc type, and our final safety analysis. Okay, this is our group members. First is me myself, IBRAHIM bin NORAZHAR SHAH JEPTAK. Second one is AMIN MUHAIMIN bin ALIAS. Third is MIQDAD bin SUHAIMI. And last one is ISMA DANIAL RIDZUAN. Okay, for the second slide is material properties. To begin our analysis, we first define the material properties of this brake rotor. We utilize a material with a Young modulus of 200 gigapascal and Poisson ratio of 0.266. Crucially, for our later safety calculation, the yield strength of this material is set to be 250 megapascal. We also accounted for a density of 7,869 kilogram per meter cube and a thermal expansion coefficient of 1.17 times 10 power of -5 per degree Kelvin to ensure a realistic simulation environment. Okay, for this next slide is structural result for solid disc rotor. This is for static solid disc. So moving into our result, table 2 summarize the performance of solid disc rotor under 3 different load. At 5 Newton load, 500 Newton load, the maximum von Mises was 1.4 times 10 power of 6 Newton meter square. As we increase the load to 2000 Newton, the stress rose slightly to 1.41 times 10 power of 6 Newton meter square. Finally, at 4,000 Newton, the maximum stress reached 1.57 times 10 power of 6 Newton meter square. Throughout this test, the translation displacement remained extremely low, peaking at only 0.000451 millimeter under the highest load, indicating high structural rigidity. Okay, for this next slide is frequency properties for solid disc. So we also examine the frequency properties of the solid disc rotor as seen in table 3. Interestingly, while the maximum one mistress value recorded here were significantly higher, reaching 5.4 times 10 power of 11 Newton meter square, the minimum translation displacement remained at 0 across all load level. This frequency result provide a different perspective on how the rotor react to dynamic forces compared to the static structural load discussed previously.
Assalamualaikum. Now, let's conclude the table for the material properties of disc brake rotor for the ventilated disc. As we can see in the slide, we have 3 different loads, which is 500, 2000 and then 4000, and also have some outcome for the experiment. So, for the outcome, we have maximum von Mises stress and minimum of it, also the translation displacement. As we can see from the value, if we increase the load, the maximum von Mises stress also increase. Same thing happen to the translation displacement. If we increase the load, the displacement also increase. Moving to table 5, which is a frequency properties of disc brake rotor for the ventilated disc. As we can see in the table, we also have 3 different loads, a 500, 2000 and 4000 Newton. And we also have some outcome, which is a maximum von Mises stress and minimum of it, also the translation displacement. So, for the value, as we can see, if we change the load or increase the load, the value is still the same for the maximum von Mises stress and the translation displacement, the same for the all 3 different loads. Moving to the next slide, let's calculate the safety of factor. Formula that we use to calculate the safety of factor is yield strength over maximum von Mises stress. As you can see, this is the calculation of solid disc rotor for safety of factor. We have calculated every load that include in this experiment. Using the formula, we have get the safety of factor for 500 Newton load, 2000 Newton load and 4000 Newton load. We also calculate the safety of factor for the ventilated disc rotor on every different load. Using the formula, we have found that safety of factor of 500 Newton, 2000 Newton and 4000 Newton. So, let's compare the result for safety factor for different type of geometry. As you can see in the table, this is a table of safety factor comparison for 3 different loads. The solid disc rotor shows a higher factor of safety than the ventilated disc rotor for all applied load. For the solid disc, the factor of safety is 178.6 at 500 Newton and 177.3 at 2000 Newton and 159.2 at 4000 Newton, showing that it experienced lower stress and maintained at a high safety margin as the load increased. In comparison, the ventilated disc rotor has lower factor of safety values of 148.8 at 500 Newton, 147.9 at 2000 Newton and 89.0 at 4000 Newton due to stress concentration caused by the ventilated hose. Although the ventilated disc has a lower factor of safety, both these types are still considered safe since all values are well above 1, with the ventilated disc also providing better heat dissipation during braking.
So we continue with discussion. Okay, this analysis evaluated the structural performance of solid and ventilated disc using Von Mises stress and factor of safety under different braking loads. From the results, it is observed that Von Mises stress increases as the applied load increases for both rotor types, which is expected due to higher braking force acting on the disc. The solid disc rotor shows lower stress values and more uniform stress distribution because of its continuous geometry. This results in a higher factor of safety for all load cases, indicating better structural strength and load carrying capability. In comparison, the ventilated disc rotor experiences higher stress, especially at higher loads, due to stress concentration around the ventilation holes. This leads to a lower factor of safety compared to the solid disc. However, all safety factor values remain well above 1, meaning both designs are structurally safe. Although the ventilated disc has a lower factor of safety, it provides a better heat dissipation, which is important for reducing brake fat during repeated braking. Therefore, the solid disc offers higher structural safety, while the ventilated disc offers better thermal performance. Lastly, for conclusion, this lab successfully achieved its objective by designing these brake rotors and performing structural analysis using the finite element method. The results show that the solid disc rotor has lower stress and higher factor of safety, making it structurally stronger than the ventilated disc rotor. Meanwhile, the ventilated disc rotor, although having a lower factor of safety, remains safe for operation and offers improved heat dissipation. Overall, this study improved understanding of brake rotor design, stress behavior, and the effect of geometry on safety and performance in automotive braking systems. Thank you.